30, section 5.1, number 10, and we're talking about writing equations for sine and cosine given a graph. So number 10a says determine the period and the amplitude of each function in the graph. Okay, so just as a way of refresher, the period, okay, the period is how long is one complete, cycle here. So if you think about this blue graph A, how long from beginning to end of a repeated cycle, what is that length? And so this is pretty easy for A. So for A, the period is, it goes from 0 to 4 pi. So it looks like it's 4 pi minus 0 or just 4 pi. Okay. For B, now for B what we have to look at is we have to look at a starting point. Now you could say, oh, I'm going to go a starting point right here on the y-axis there. That looks like a peak, right, of that graph. And I'm going to go to the very next peak, the start of the next repeated cycle, or from the beginning of one cycle to the very end. And of course you see this is from 0 to pi. So for B, it goes, the period is pi units. Now you could have done this and say, hey, I'm going to go from here to over here, because this is where I have one complete cycle, and then it starts again over here. And of course you could just subtract the difference there. Okay, so you could take this one and minus this, and then that's your okay. So that's going to be pi as well, right? So that's 7 pi over 4. 2 looks like that's going to be 11 pi over 4. Yeah, so the difference there is 1 pi. Okay, so that's A. Now B is the question that you were most interested in. So B says write an equation in the form of y equals a sine bx or y equals a cos bx for each function. So the period is important, and also the A represents the vertical stretch, right, or the amplitude. A is amplitude. So let's go back. I'll use blue here for graph A. Okay, so period we know is 4 pi, so that's going to be great. We're going to have to use that here, right? Now B is not 4 pi. I'll get to B in a second, but the period length, or the period, it determines what B is. And the amplitude, okay, so what we need to do is imagine a midline that connects the sort of beginning and the end of the cycle. This is the midline, the x-axis. What is my amplitude? So from the middle to the top, or from the middle to the very lowest point right here, what is that distance? So it looks like it's 2 units, isn't it? Okay, so the amplitude is half of the displacement from the maximum point to the minimum. That might be easier to do in some cases. You take the maximum point, subtract the minimum point, and then that difference there divided by 2 is the amplitude. So A, the amplitude, is 2 units. Okay, now what do we know about B and period length? Well, you should have remember from your lesson that period length is for sine and cos is 2 pi over B. Okay, that means that B is 2 pi divided by the period length, if we just rearrange this equation. So what is B for A? B for A. B is 2 pi over 4 pi. So the B value is going to be 1/2. So here we go, we've got B is 1/2, and the amplitude is actually equal to A. Okay, so I think it looks like for B here, for this A graph, y equals, now is this going to be sine or cos? Well, this one starts at 0 and it goes up in the positive direction, and then this is a sine shape. So I think it would be wise to use sine for this one. And so we'll just do y equals 2 sine 1/2 x. Okay, so you can double check that for B. That's for the A function. And then I'll go through what that looks like for B as well. Okay, so just confirm with me that you're okay with that answer. I don't have the answers quite in front of me here right now, but I'll let you guys let me know if that's true. In red, we already know that the period, okay, the period is pi units. So we know that b is 2 pi over the period length, 2 pi over pi. So b is going to be equal to 2. Okay, that's excellent. What is the amplitude? So from the midline to the maximum displacement, looks like it's 0.5. Do you see that? From the midline to the maximum displacement, or from the midline to the minimum, it's 0.5. So A is going to be 0.5. Now we have to pick whether we're going to use a sine or cos. And to help you decide that, what you might want to do, because you know that a y equals sine x starts at 0, 0, and goes up to a maximum, down to a minimum, and then back up to that. This would be an obvious probably choice for sine. The cosine starts at the maximum, doesn't it? At y equals or at x equals 0, it starts at a maximum and it goes down to a minimum, then back up to the maximum. That's the general shape for y equals cos of x. So I think it would be wise for us, so we don't have to shift left or right. I think it would be wise for us to use, for the red graph, use cosine. So we don't have to shift it left or right. Okay, no transformation that way, no translation. So we could go y equals 0.5 times cos of 2x. And that would be the equation for b. And then c, explain why. Well, I just sort of explained that because these graphs right here, the blue one, looks an awful lot like y equals sine x with no translation, left or right, no sliding. And the b, red graph, looks an awful lot like cos of x with no translation or sliding. So you can probably understand we don't have to include any kind of transformation on x, any kind of sliding left, right, and no other, no other vertical translation component. Okay, so that is number 10. Hopefully that helps.